So, your time is now. Go for it.
Thank you. So I'm going to present our solution for Rittal. And first of all, I'm going to quickly tell you in a nutshell what I'm going to be talking about. So basically, the core of our solution is that we're going to do predictive maintenance in a different way, in a way which differs from traditional approaches to predictive maintenance. And secondly, on top of that, so by doing predictive maintenance in a different way, we pave the way for an algorithmical prioritization of your maintenance appointments. That would be the second building step, the building stone. I just want to point out that Trevisto AG is not a blank page when it comes to deep learning and applying deep learning to industry problems. We did projects in the past, prediction, and that's just here to tell you that we're not a blank page. But now let's come to our solution. I want to start by pointing out to you the advantages of our solution to you. That's going to be from the technical point of view. And it's very important for you to know that our solution does not need labeled data. If you do know about machine learning, then you know that you need a data record and you need to have some metadata, some label describing what happened at that point. So you have your sensor data, your timestamp, and you have to know what happened with your machine at that point in time to apply traditional machine learning approaches. You need to have a historical track record of your machine failures. With our solution, you don't need that. You won't need that. You will be able to, without having that long history of your failures, you will be able to apply our solution. Our idea for predictive maintenance, in a nutshell, is to come up with a score that summarizes your machine's condition in one single score. It encapsulates the machine condition in one score and lets you easily tell how your machine is doing, whether your machine is healthy or whether your machine is not healthy, whether it needs to be serviced or doesn't need to be serviced. The advantage of having one single score indicative of machine health is that you can rank your many machines and you can see quickly which machine needs attendance, which machine you have to attend to. So you are going away from your sensor data level where you have dozens of sensors that you have to look at and that you have to keep an eye on. That's just a processual view of what we're going to do. So we're going to collect sensor data, obviously, or you're going to do that for us. We're going to calculate that one score, which is indicative of machine health. This score is going to be fed into a dashboard where you will be able to assess your machinery and see how your machinery is doing, how volatile it is behaving, how machine condition is deteriorating or not deteriorating. And that's the first part of the solution, because I've been talking about a two-tiered solution. Once you have that score, once you can see how your machines are doing with that score, you can add to this information what your technicians are doing, where they're going, where they're doing maintenance, and you can then algorithmically prioritize which appointments to do first. So you can have an algorithmical prioritization of your maintenance appointments. That's going to be the second step. So that magical score that I'm talking about, what is it? So we're going to have a deep neural network, and you'll have a newly serviced machine. It's very important. It's very important to have a newly serviced machine which is in good condition, where we have done our maintenance and where we have our technicians who can tell us that machine is a good one. It's working how it's supposed to work. Now, it's important to look at the circle. You will have your data coming in. Look at the circle. The data will come in, and with the data coming in, we will be able, with our neural network, with our deep learning, to establish what constitutes a normal condition. We'll establish what is normal for a machine. Once I've established what is normal for a machine, I take that model. I have learned what is normal. I take that model. I have a running machine, and I have the sensor data coming in. That sensor data is being fed into our model, into our deep learning model. And again, we see that our data is coming in. Look at the circle. The data is coming in. But now the data, our machine, you can see the yellow dot over there, has gone beyond what is normal. Our sensor, underlying sensor data has changed. And the machine, the data that comes from our machine, moves further away from what is considered normal. And again, it moves further away from what is considered normal. And that is our machine condition score. So look at the distance between the center of the green circle and where our dot representing our machine condition is now. So we establish it via the distance. And that gives you the ability to monitor your machines over time and to see how its condition is changing and how fast it is changing. So coming to the dashboard part of our solution, once you have that score, as I told you, you can then rank your machines. And this ranking, as you can see here, is by the machine's deviation from its normal state. So you will have a list of your machines, maybe you have hundreds of machines, and the bar length here indicates how far your machine is from your normal condition. And the longer the bar gets, the worse it is. The red line here indicates that you have where you've had failures in the past. You can connect this information with geo-information, and then, for instance, if you have, we also have our rate of change of that machine condition score. And once you know how fast the machine is changing and how bad it is doing, you can then decide on the map whether, for instance, you want to do 2 maintenance appointments at one time. If you have one machine which is doing average and one which is really bad, and you know the one which is doing average changes really fast, you can then combine these appointments, for instance.
We can give you 30 more seconds.
You have the underlying machine data, which lets you drill in and see why a machine condition score is bad. So you will be able to come back to the original data. That information, what your service technicians have done in the past, your machine condition score, your rates of change will allow you to, at one point in time, prioritize algorithmically your maintenance appointments. That's going to be a second step, but you'll have to gather data first. Your advantages are obvious. It's cost reduction. It's maybe an increased customer satisfaction due to less failures, and you'll be able to improve service level agreements. But you can decide what's going to be your advantages. So yeah, thank you.
Thank you also, Alexander from Trevisto. Sorry for the pressure here at the end.
Yeah, it was.
We got to keep it fair for everybody. 7 minutes presentation time. So we'll get Oliver on stage also for some questioning. Now, thank you very much. I like the clear pictures. The structure of the presentation is what I really enjoyed. What about the jury? You probably have some questions.
Yes, thank you very much for the presentation. First question I have, will you be the team lead?
Probably.
How probable?
Yes.
Yes.
Yeah.
Will he be the team lead?
We're having a team of about 40 employees, and if it comes to a project like this, I think we have a project group of about 6 or 10 employees who are working for a project like that one. Yeah.
And I understand...
Depends on the size of the production sites and so on. Yeah.
Okay. And I understand this is something you've done before, right? You're industry veterans. So how much does this deviate from your core product? How proven is it?
We had always projects in the past which dealt with predictive scenarios. Yeah? For instance, in the industry, when it comes to optimize order entry processes, or if you want to monitor the product quality, we had an example and reference case in terms of film production. And if you can predict how the quality will be, at the end of the day, you'll be having a better solution than your competitor.
So we've done deep learning. We've implemented this thing here, but we've implemented it in our kind of lab to test it. Our deep learning solutions deviate because they were more traditional deep learning solutions, but that one, it has not been tried in the industry yet. But we've tried it in our lab, and it's a way to go forward. And that's why it's special, because it deviates from what's normally done.
Dude, I can see you're super passionate about this.
Yeah.
I like that. Okay, let's move it over. What does our jury think? What do you think?
Well, thanks for the presentation. Very interesting. I have a question regarding the machine score that you came up with. How long does it typically take to come up with the normal condition? So you have that as part of your system, and you can actually evaluate once or when you're deviating from the normal score.
Well, it's a really good question that can't be answered easily. Normally, I mean, we would need a technician who can certify that the machine is running normally. Once you have that, and you actually not that much data would be needed to establish how a machine works. So it would be able to. I mean, I think it would be rather quickly. So we don't need much time for that. It's just about the condition that somebody says, okay, that machine is running fine, and we take a data sample of, for instance, 1 day or 2 days. I don't know how fast your machines are changing their condition, how fast they're deteriorating, but if they're not going bad so that quickly, so if they're maintained probably every 6 months, then if we get 2 days, 3 days of records after the machine has been serviced, we can train on that. So there is no lengthy training or data gathering involved.
Okay.
So, yeah.
Stephen has a question.
Okay, a couple of questions. First, help me with your differentiators. It seems like a lot of people could do the same thing.
Well, I think it's a resourceful solution. I don't think that predictive maintenance is done in that way in the industry. There have been a lot of many people have tried to do predictive maintenance using labeled data, as I've pointed out before, and that didn't work because the approach with labeled data, so where you have a history of failure, and then have that meta information, try to learn from that, that didn't work because the reasons why a machine failed, they differ all the time, and failures are very, they occur rarely in many industries, and therefore it didn't work. And I think that our solution is a good one. So it's a different kind of neural network, and I don't think that everybody would be able to do it because it requires some good understanding of neural networks, and also you need to be able to. There's a lot of tuning involved. And we were able to, we have a kind of algorithm to tune our neural networks, so that we don't need so it's about finding the right architecture also in deep learning, and we can do that very well. So that would be one differentiator comparison to other.
My last question is a business question.
Yeah.
How scalable is this? I mean, you're really describing a very specialized capability in a very tuned environment in order to be able to execute a service. I mean, how many services can you do? How many companies? I mean, what's the scalability factor here?
Well, we have an ideal scenario of a machine running in an optimal way. And if we have this standard, then comparison to other machines and other production sites is relatively easy. And so in terms and with the MindSphere solution together, it is highly scalable. Yeah? So if you have a standard, and then you can observe the deviation from the standard.
I mean, scalability is more. It's more a take. It's up to the. It's up to technology. The scalability. the solution you're implementing does not have to, I mean,
Yeah.
it doesn't have to do with manpower, but it's about the underlying technology and how scalable it is. And
Yeah,
it
I guess-
scales with the platform.
Yeah, let me be clear. I'm sitting here saying to myself, do I need 5 of you or 50 of you or 500 of you?
Yeah, you'd rather need 5 to 10 of us, not 500,
Okay.
because once you you establish the process, you can apply it and multiply it. Yeah.
Okay. I thought it was a business-related question. So if we talk about scalability, we just have to start at some point. What would be your proposal to Rittal? How should they start this new business model and offer it to their customers?
We're starting with a proof of concept scenario. So we have really to have some workshops together in order to understand the business process itself in a better way. And then we go on and move forward and implement it at one site, for instance, at one machine, and go on. And if we have seen so much data that we can say this is the standard, then we can go on and automatically pass.
Then it's easily multipliable once you've established.
But start with a proof of concept. Yeah.
We'd have time for one more question.
Okay, regarding technology again, so how do you learn what is more or less important in terms of a sensor going out of the normal? Because this, for your prediction, is key. And
Yeah,
for
that's a really,
for saving costs is key.
I see where you're going there, and that's a really good question. My answer to that would be that you have to talk to a technician who knows the machine well in order to only tap into sensor data, which could indicate failure. So you only tap into the sensor data that really directly has a direct, strong correlation with failure. So the key points. But you have to talk to a machine, to somebody who knows the machine well, to somebody who has built the machine probably, who can tell you these 5 sensors, for instance, are the ones where we're going to see some flux, some deviation, some volatility once the machine goes beyond what's normal. So you'd have to identify it through one technician. Yeah.
All right, and we could get into more detail, but the time is up. So why don't we give them a big round of applause? Our first presenting team on stage, Trevisto, Oliver and Alexander. It wasn't that bad now, was it?
Yeah, it was okay.
They didn't eat you up. Well, nice guys here in the audience. So thank you very much for going up first as the first team. And this is also your chance to vote. If you think, hey, Trevisto, I like the idea, I like the presentation, go to siemens.com/vote now.